Let me just throw a couple of questions out to you. How many of you guys are analysts? Developers? And the rest are testers in one form or another. How many in operations? Which is a shame. You're from operations. Cool, because what I'm going to be talking about today is DevOps. And probably all of you, or most of you, have heard about DevOps. Just give me one interpretation or one definition of DevOps from, say, yourself. What do you mean by DevOps? What do you understand of DevOps?
Operations of how something is developed.
Okay, that's one interpretation of it. It's almost like that dot signal. All right, so what I'm going to do today is talk about DevOps, but I'll use DevOps as a contextualization for what I'm really going to be talking about. And we're really talking about practice called continuous testing. And continuous testing is really part of continuous delivery. Continuous delivery, I'm sure you've all come across, is how do we do things better, faster, cheaper. And I know this is, I've only got half an hour, so I'm really, it's a whistle-stop tour of the whole thing, but I'll be available later on to answer questions and hopefully dodge a few as well. Another thing about whoever asks the most interesting question is going to get a prize, because some prizes like those things. So be alive, be awake. Hopefully I'll get some ideas going. Okay, so let me go straight into DevOps. DevOps is really a practice. It's part of a wave of change that we are experiencing within IT at the moment. And just to contextualize and give you a history of these waves of change, some of you might have seen in a similar slide or a representation of the waves of change. You know, it's from the good old mainframe days, and by the way, this is not to say the mainframe is dead, anything but. It's still around and it's still here to haunt us, or us in the software development lifecycle. The operation of people around mainframes was always, bring work to the mainframe, the ops center, where the cards were cut and and the rate of change was slow, but it was stable. And it still is to some certain extent, mainly because of the disciplines that were enshrined and entrenched in mainframe operations, including software development. Things have changed. Network, decentralized computing, PCs, all of that stuff came along. As you can see, software distributed, both server and client computers, great. It was the great nirvana, the wonderful things. Everything is going to change. We're going to become more flexible. We're going to be more agile. Sorry, agile was not invented then. But that's really what it's all about. And then it's internet and cloud, which is really where we are currently. It's still trying to deliver on its promise. And I think most of us have realized that it is. It's a major change. And we are almost taken it for granted now. Every app on your cell phone, more often than not, will connect to something happening in the cloud somewhere. Loose coupling. Some of you who have been involved in service-oriented architecture and the decoupling of software and hardware and all that good stuff, you'll understand that a little bit more. And then, of course, DevOps. This is where we are now. How do we use DevOps to do things better? All of us are in an IT shop of some sort. We've always been, if you like, holding our businesses to ransom. And I know it's a very radical thought, but just think about it. IT people were always considered those untouchables. You go to a party and you say, well, somebody asks you, well, what do you do for a living? Oh, I'm in IT, and then they'll walk away because they don't know how to talk to you. I think some of you will have come across it, yeah. But of course, it's changing, but this is really what it's all about. How can IT, and us as practitioners in the IT departments, IT divisions, or in software development companies like here, how can we do it better? How can we, not suddenly, but how can we now be influential in the bottom line of a company? Be it an insurance company, be it a retail outfit, be it a software development house. That's what DevOps is all about. How do we optimize the organization? So one of the things is really about rapid application delivery. We need to get things out there faster, but not at the expense of quality. Now we are all here because of our software quality and how do we test for and improve quality, etc., etc. Near zero defects. And I say near zero because I don't think we will ever get to a situation where we can do it and no defects ever pop up. It's human nature. Software development is part of human nature, and we're not infallible. That's the reality, and I'm sure you all agree. And of course, the industrialization of commercial software development. Now you're probably thinking, what the hell is he talking about? Industrialization of software development, I mean, and we at CA are talking about the software factory. If you all ask yourselves what you normally do, and especially the developers, what you actually do. And by the way, remember, right at the very beginning I said information transformation. I know it means information technology. We all say it's information technology, but what we really do is just transform a piece of information into another form. That's all we do. We don't do anything else. That's what software development is all about. And information transformation is what we're talking about. And industrialization is to making software development as quick and as effective as possible. That's what happened with the Industrial Revolution. The assembly lines, with Ford coming up with the first assembly line, he could get things done faster at a consistent quality. And that's what software development is all about. Not all software development, and that's why I say commercial software development, which is like the stuff that happens in banks and insurance companies and retail outfits, etc., etc. In terms of really creative software development, very little. If you want real creative stuff, you go into AI, you go into gaming. That's where the real creative stuff happens. Us testers are always the poor cousins in the life cycle, unfortunately. And we pay the price for it, because we always get things thrown at us towards the tail end, hoping we will fix problems. Of course we don't. So what I'm going to be talking about is how do we improve that. Okay, so that's the context of DevOps. Now what I illustrate DevOps in the form of a temple. Every temple, like every building, requires a foundation. And this foundation is about organizational change for greater collaboration. That's what we're talking about. Collaboration from the role players in the life cycle. From the analysts at the beginning to operations if you want to do a serial fashion SDLC. But in the end, it's all about all players. Now, at the back of the shirt, we say testing is everyone's responsibility, which is absolutely true. From a BA, from a developer, from a tester, from an operations guy. And I will illustrate that, what I mean by that. The first pillar in the temple is all about release automation. Because if you go back to why we are doing DevOps, we are doing DevOps because we want to improve things. Where are the problems? It happens to be in things like release automation, or managing releases, or state of change of software from one state to another. In all organizations, and there are bar none, it's a mess. It's a pain. People get by it, but at a cost. What we're trying to do is to improve that. And of course, there's lots of tooling and professional services that go with it to make sure that you use the tools in the right way. We had a game outside, which is about the hammer and nail. The reason why we use a hammer is because you can get more nails in faster. It's a great tool. Otherwise, you'd be using a rock. It doesn't work. That's what tooling is all about. Make things go faster and better. And can be used by pretty much most people. Except some of us who tried the hammer and it didn't really work. Okay, so release automation is one of them. The second one is service virtualization. quick, how many people have heard of service virtualization? It's 1, 2, only because I've told you before. 2, very few. But this is a silver bullet in software development and also in software quality assurance. But it's the light bulb that hasn't gone on. Service virtualization, by the way, is not server virtualization, which is the virtualization of hardware elements using VM and OWare and all that stuff. This is about how do you simulate the behavior of software, even before the software has been developed. And that's what we're talking about. I use normally an analogy of airline pilots. Airline pilots cross-training from, say, a Boeing to an Airbus doesn't say, well, let me just put an L plate on it and let me take the plane up. Thank God it doesn't happen. But how many of us, when the next time we fly, even bother to ask the question, how much training has a pilot received? They've received a lot, but most of it is done in flight simulators. That is pure software. And this is what we're talking about. Simulating the behavior of the software that you guys do the testing on. Because more often than not, a lot of that software is not available for you to test. For a number of reasons. It could be that that app that's sitting out on a third party is not available, or you haven't paid your bills so you don't have access to it, or it hasn't even been developed. It's a figment of somebody's imagination. But the designers have already started. So you can take the output of some of these designers and create services, which you can use as testers to simulate the behavior in an integration phase, for example. So that's a very quick overview of service virtualization. It's simulation of software. The next one is test data management, the bane of every tester. I don't have the data. Where is the data? The data is crap. I don't have enough of it. You want me to do stress testing and I've only got 10 records. I don't even know what the coverage is. You probably have been asking the questions, or you've been hearing colleagues in the corridors saying, what the fuck is going on here? This is what we're trying to solve. And we have a mechanism for solving it. Is to provide testers the right data at the right time in the right place. That's what this is all about. It's representative test data. There are a whole bunch of other goodies that come with test data management about how do you protect confidential information, which is, unfortunately, whether we like it or not, is a reality. It's called POPI or GDPR, and some of you might or might not have come across it. The legislation is just around knocking on our door. When that happens, we are going to have to change the way we do things. Because otherwise, the company is going to say, you know what, we are in breach of GDPR, for example. GDPR is an act that's been promulgated by the EU, and which says that any company that's going to do business with any company or country in the EU has to follow the guidelines of GDPR. GDPR stands for General Data Protection Regulation. It puts a whole bunch of obligations on us testers because we require data.